This video demonstrates the two types of process models used by the PIDBot tuning dashboard component. We have the first order plus dead time process model and the integrating plus dead time process model. We're using tank level control as an example here, but these two simple models can be applied to a wide range of systems for PID tuning. The first order system is sometimes called a self-regulating system. That's because if we change CV, the PV will eventually reach a new steady state on its own. In the case of the gravity drain tank, our CV is pump speed. And I'm just going to decrease pump speed from 40 Hertz to 30 Hertz. And that's going to cause flow to decrease into the tank and level to drop. But as level drops, so will the pressure at the bottom of the tank. So outflow is also going to begin to decrease until a new equilibrium is reached and level steadies out. And it looks like it's going to steady out around 6 feet. That is not the case with an integrating process. With an integrating process, the outflow is completely independent of tank level. So if I were to change my CV in the pump tank case here, let's say I'll change pump speed from 35 Hertz to 45 Hertz. When I change CV, tank level is going to begin to change and will continue to change. There will be no steady state reached, but the trajectory of the change in tank level should remain the same. And we see that's happening here. It will continue to decrease in tank level until it's completely empty, or I change CV again. And so I'm just going to decrease the pump speed, and we should see tank level start to come back up. And again, that trajectory in tank level should be constant until either CV is changed again or we overflow the tank. So I'm just going to change that back to 35 Hertz, which gives us a pretty steady level. So when you're deciding which process model to use with the PIDBot tuning dashboard component, take a look at whether or not your process is self-regulating. If it's self-regulating, use the FOPDT model, and if it's not, then use the IPDT model.